This first part of the problem asks us to find the domain of x over the square root of x squared minus 2x minus 8 graphically. Now just a reminder, until we hit logarithms and exponents and trig functions, when someone asks us for domain, what we need to do is make sure that we eliminate all x values that make bottoms 0 and eliminate all x values that make insides of square roots negative. So what we do is I'm going to look inside the square root, and we know that we're going to need the inside of the square root can't be negative, so we know we're going to have that. And that'll make sure that the inside of that'll make sure that the square root is defined. But it's also on the bottom, right? And so it can't ever be 0. And so what we're going to get here is that what we need to find the domain is we need to solve that polynomial inequality algebraically. So what I'm going to do is just solve that polynomial inequality algebraically, and we know then that we'll have our answer. So I'm going to write down solve. And how about something like x squared minus 2x minus 8 bigger than 0. Now, the way we always solve these is we get 0 on one side, a single thing on the other side, all we have is the polynomial. Then we factor. I'm going to factor, this factors is x minus 4 times x plus 2, like that. Now, we don't divide by stuff. What we need to do now is we make a sign chart. We can do this with lots and lots of cases. The sign chart actually takes care of all the cases at once. I'll run through the procedure here. If it doesn't look that familiar, go to that link in the notes to Paul's online notes. They have at least 10 worked out full examples of exactly what we're going to do right here. What we do, we set each of the factors equal to 0. So for example, here I'm going to get x equals 4. Here I'm going to get x equals minus 2. And what do we do with those? We go and we make a sign chart out of them. So I'm going to make a sign chart. The x values are going to go down here. The function values are going to go up here. So I'm going to put a little copy of our polynomial right there. And I put each of these numbers on the sign chart. These are the only numbers that actually go on the sign chart. Get in the habit of always taking these numbers and plugging back into the polynomial to see what we get. When I plug minus 2 in here, I get something times 0. Well, something times 0 is always 0. When I plug 4 in, I get 0 times something. Well, 0 times something is always 0, so I get this. Now, what we need to do now is pick a test value from each interval. I see 3 little intervals here, and I need to pick one number. I tend to pick things that are far away if I can, like x equals negative 10. I put a little box around it to let everybody know that's not one of the numbers that's on the number line. It's just a number I'm plugging in. When I put negative 10 in there and negative 10 in there, I clearly get negative times negative. Well, that's going to be a positive answer. I'm not saying that negative 10 is positive. I'm saying when I take negative 10 and plugging it in here, I get positive. I now want to pick a number between minus 2 and 4. I think x equals 0 is the easiest number. So we're just going to write down x equals 0. And what do I do with the x equals 0? I put it here and I put it here. When I put 0 here and 0 here, I get minus 4 times 2. That's negative 8. That's a negative number. That's all I care about at this point. Well, I now want to pick a number that's bigger than 4. How about something like 10? Usually the bigger the better. If I put a 10 here and a 10 here, both are clearly positive. Positive times positive is positive, and I'm going to get an answer that looks like this. Now, remember what this says. This does not say that negative 10 is positive. It says that when I plug a negative 10 into this, I get a positive answer. Now this, by the way, is going to tell us that no matter what number I plug in back in here, I'm going to get a positive answer, because the only places where this polynomial can change sign are here and here. So if it's ever positive once out here, it's positive the whole time. Same thing here. I'm not saying that 0 is a negative number. I'm saying when I plug 0 into here, I get a negative answer. But that's then going to tell us that no matter what number I plug in here between minus 2 and 4, I'm going to get a negative answer. Same out here. When I plug in 10, I get a positive answer. That's actually going to tell us that no matter what number I plug out here, I'm going to get a positive answer. We now have enough data to write down the conclusion. I'm going to write down the conclusion in the middle in orange. So I'm going to say conclusion we looking for? We want the places where the polynomial is positive. Well, the polynomial is positive way out here and way out here. How do I describe these numbers out here? These are numbers that are less than -2. These are numbers that are bigger than 4. And usually what they do is they'll put the word or between them. Because the number can't be less than -2 and bigger than 4 at the same time. So this is the domain we're looking for.